which is essentially equaling units in the positive x direction, so 3.00 units. And we can say I hat. And then for vector b, we have 4 units along the negative y. So it'd be 4.00 units along the negative, we can say negative j hat. So at this point, we can say that our vector for part A, vector A plus vector B, is simply going to be equaling, simply enough, 3.00 units I hat plus 4.00 units negative j hat. Now, if we wanted to find the magnitude, that would be a bit different. We could say that this would be equaling the square root of the magnitude of vector A squared plus the magnitude of vector B squared. So this is equaling the square root of 3.00 squared plus 4.00 squared, and this is equaling 5.00. So that would be the magnitude of the resultant vector. Our theta angle would be arctan of the y component over the x component. In this case, it would be 4.00 divided by 3.00, and this is giving us 53 degrees. Now, remember, you have a positive x and a negative y, so you're actually in the fourth quadrant, where, again, we have a positive x, negative y, so you're going to be 53 degrees below the positive x-axis in order to place us in that fourth quadrant. So this would be the direction, and then this would be the magnitude of the resultant vector. Now, for part B, we have essentially the exact same thing. However, here we have A minus B. So for part B, we have vector A minus vector B. So here, this is going to be equaling 3.00 units. Of course, vector A doesn't change, I hat, plus 4.00 units. And because it's negative B, we are actually in the positive y direction. So this would be j hat. And so we can then say the magnitude would be the exact same, again, 5.00. And the theta, the angle, would be equaling the exact same angle, 53 degrees, but now we're in the positive x, positive y, which means that we are in the first quadrant. So this would be 53 degrees above the positive x-axis. So these would be our two answers for part B. That is the end of the solution. Thank you for watching.